Well, hi, good morning, and thank you for joining me here in my shop. I'm going to take another day of effort on this radio. I've already done a little bit of effort since the last video. So I played this radio on the last video, and along with working surprisingly well, there was a hum in it. So the hum is controlled by some big capacitors. Big one up here in a metal can, and a big one down here. So I took a look in the schematic. It turns out this is actually part of the power supply. I thought this might be a bypass capacitor, but it's not. It's on the output leg. There's two capacitors in the power supply as usual, with a choke in between. The second one is this one. So you know, these guys with just a cardboard cover aren't particularly reliable in the long run, and it's been a long run. My own experience, these guys in the metal can, sometimes they're in pretty good shape even after a long life. So if you look careful enough, you'll see the wires are cut off of this now. You can see the wire cut here. And the new capacitor's right here, this little black thing right here. And that's the connection wire. So I put that in last night. That might be it for the hum. But the strangest thing is where my clip lead is connected. I just walked in here last night deciding to do this little bit of work, and what I noticed, without touching anything, is this capacitor is free in here. It's in exactly the same position. I haven't moved it, at least as far as I know. I haven't moved this at all. You know what I should do? I'm going to stop. I'm going to look at my my video of where I'm inspecting this this radio, and see if I don't catch this on video and show where it is. I tried to figure this out from the schematic. I couldn't. I just couldn't figure out where it's supposed to go. You know, conceivably right here, but there's no reason to think it's supposed to go there. It doesn't even make sense. It doesn't follow the schematic. So where this has really come from, you know, there's a big range of possibilities here for this capacitor. So I'm just going to stop. I'm going to take a look at the video. See if we can sort it. See if I can sort it out from that. Well, I did manage to find it in my video. I've got the point where I'm lifting this up for the first time and revealing what's underneath. This capacitor is sitting exactly like you see it now, with this wire clearly not connected, sitting like that. So, I operated the radio without it, and the radio seemed to work. This side of the capacitor is going to the chassis, or going to ground. This is the only one that we got to wonder about. As I say, I looked and looked. I couldn't find where it went. So one of the ways I can resolve this is to start replacing capacitors, which is probably where I'm heading today. In fact, replacing all these wax capacitors. And as I do them, this is a .02. There's a number of .02s up here. I can identify these on the schematic without a doubt and mark them off. And at some point there'll be one .02 left on that schematic. It'll have to be this one. So that's how I think I'm going to approach that. Otherwise, I think I'm facing a major guessing game. So I think what would be interesting now too, bend this up a bit, would be to play this radio again and see if the hum has gone away, if that's all it took. Get rid of it. Okay. Then I want to put an antenna on it. Have a nice listen to it here. Oh, you know what? This time this antenna is definitely not switched outside. I'm going to have to run and throw a switch on, but let's just see what happens with it like this. Okay, power. Happened here. We're at 86 volts. It might be just a little low. Let's take it up a little higher. 100 volts. I don't hear a sound. That's not a good sign. Not a sound. Oh. No antenna. Okay, so it's on shortwave. You don't hear a thing. I'm going to go throw that switch. I'm going to turn this down. I'll throw the switch and come back. Just take me a second here. This is good proof the antenna actually works. Yeah, there we go. Okay. Thought it was off to a bad start. AM. Is that that? Yeah, it did this. Climbed over the pulley that's behind here, the pulley that's not being used, and popped off the pulley right away.
An interest? Oh, $10. Hurry, we have even more. Conditions apply. Buy now. Don't.
Somewhere around here.
What's the discussion?
Beautiful.
You also had something about
Canada is helping those who need it most. Because we're all connected for good. Learn more at tellus.com.
Beautiful.
Mais en venant de Buffy Saint-Marie, une femme qu'on admire beaucoup en tant qu'artiste, en tant que femme autochtone, mais je pense même au-delà, je pense que beaucoup de monde aime Buffy. C'est beau aussi de savoir que c'est un auteur-compositeur. Je pense que c'est important de...
Lots of volume.
Parce que souvent on pense à...
Beautiful.
Ses côtés
What am I going to do?
activistes et son côté... qui parle de les problèmes sociaux qu'on peut avoir.
Hum appears to be gone.
the light.
Wonderful. Okay, shortwave. Shortwave at 9 o'clock in the morning here. Starting down here. This is just the 9 megahertz band. We should pick stuff up here.
Estas no cambian nuestras vidas si nosotros no hacemos nuestra parte para absorberlas. La autora Ian Lemons dijo.
Spanish?
Stayed on duty that night. Later he told us that whilst he was in charge of Mao before bedtime, Mao, deeply disturbed,
British accent?
cried again. According to Fung, Mao had said tearfully, his back and turned back. And what is? It told me many lies. Always that life may visit.
I have to decide what to do with this radio. One thing that has to be done is it has to have a pointer fashioned for it. So maybe I'll make that my first project here, is to get a pointer onto this radio. And then I can decide what I want to do next with it. I am tempted to change all the capacitors even though it's operating. Maybe the thing to do is to mess around with it, get an idea of how well it's working, do some measurements on it, try to get a good feel for it, and do the alignment on it as it sits. And then begin picking out the old capacitors and just see if I can get a little more out of the radio after doing that. So, but it's working really quite well. It has a nice sound to it. I like it a lot. So, pointer. Okay, pointer. I have to come up with some kind of a. I have. You know what? I have a pointer somewhere. I'm gonna see if I can find it. Okay, I spent a long time looking for a pointer. I just don't have any spare pointers. I spent a long time looking because I think I do. But what I've done here is I simply clipped the wire to the slider with this clip, and also clipped a tie wrap to the front as a pointer, just to get me moving on this. Now, where did I do it? I did it in just a irrational place. Uh-oh. Well, I'll get it a little more rational here. Maybe I can just slide it. Maybe. Oh, I got a lot more to go here. Okay, so then, yeah, let's do this right. Let's just do this right here. Right now. So we're all the way over here. Let's bring it over this way. So what's happening is this is a two-string unit. The thing is being stopped by the capacitor on the back string, but then it'll slip and you can continue moving the front string. This would ruin any kind of synchronization there was between the two pointers, unless the pointer reaches a stop point at the same moment the capacitor does. And what is the stop point? There is no stop point here. Oh my gosh, well that means you can turn the knob, slip the string on the capacitor, keep turning it past the end point, and drive the pointer basically until the string kind of bungs up in there like it's doing here. Why is it even doing that? Something's going on with this string. Capacitor string is very well. The capacitor string can't slide. The capacitor string is fixed on this big wheel. This one's not fixed anywhere. That's a bit of a problem with this radio. See, so this way, if you try turning it past, you're tightening the string on here, and it's just gripping harder and harder. So you can't do it this way. But the other way. So this is a serious problem with trying to align the radio. It means the first time I slam it against the edge here, I'm going to slip it. And let's go to the other end of the dial here. I'll attach the slider. I won't worry about the pointer right now. Crazy arrangement. The thing I like about doing these radios is every radio is different enough from the last that you're facing new challenges and stuff that okay, so we're coming up to the end here. So this will bump into this little thing here. Bump. That's one end. and the capacitor is not quite there yet. So let's just get these two things to happen at the same time. So we're bumping here, and we're bumping there. Now if I kept turning this, what would happen? Well, what does happen? What does happen? Let me just make sure I feel the string up here. It's pulling hard. Now that I look at this, I think this is correct dial string. That knot is coming undone there. Looks like it's coming undone. So I usually put a little glue on my knots when when I'm done here. Okay, so that's the limit there. Now, what happens at the other end? Okay, the capacitor is closing. Well, there's about a 1/4 inch further this could slide this way. You can also see the skid marks. It's like studying a traffic accident here. You can see the skid marks on the metal right in there. And the metal made it all the way to this edge. It doesn't now. So I'll bet you it's that knocking is the capacitor slamming. Well, if we want to match where it was originally, we would go a little further down the way here. If this clip doesn't cut the string, I'll be lucky. Oops. Okay. It's right off the scale and hidden in behind here. The pointer would be in behind here. That's a little odd. What happened at the other end? Okay, capacitor closing there. So it's stopping right on the edge of the display here. And they can make it all the way to the stopper. Then if we slip the string past it a little bit, I don't know if I did or not. Go back. Okay, who hits the end of the road first? So this actually knocked into this before the capacitor closed. So this thing is shifting back and forth on the string every time you knock it on one of the ends. It'll knock back a little bit. You gotta know enough to stop there. Now, so this is a 2-bander with a short wave, only one short wave band, and the band is spread across the dial. That gives an opportunity to actually tune in based on the frequency. It's wide enough that you could say, let's tune in 9370. You can figure out where that is on the dial here quite accurately. So this radio's begging for accurate dial, and with the pointer shifting back and forth. Eventually I'm going to glue this because I don't have any other option. The little mechanical string holding tabs are broken off the back of this. So I'm going to glue the string to it when I go to do it. At that point, if you reach the end of the capacitor before the string and you drive this further, the spring is going to have to... No, there was a slip. Slip again. Yeah, wow. Okay, so capacitor's wide open, the pointer's hidden. They didn't intend that to happen, did they? The pointer's hidden here. The capacitor right there. The pointer's not hidden here. Maybe there's some instructions. Maybe there's a marker here or something. The fact is, we can actually do a little alignment fun with this radio now. I want to quickly check it. Check it out. Okay, so I'm going to insert the temporary pointer, if I can. Do this more in the middle where there's more. The other thing is I don't want this plastic dragging on the back of this dial, or it'll start knocking off the numbers. Or there's a chance it'll scratch off numbers. I have no idea how strong they are. Some of these radios, there's nothing holding the paint on, nothing at all. You can't touch it with anything without damaging it. Others, man alive, you can run it through your dishwasher, I think. Get back there. It's another case where I need another hand. Stick your hand through your computer screen and grab onto this thing for me. Come on. Just hang on there. There we are. That's good enough, for sure. Okay, let's talk on the auto alignment here. Okay, capacitors closing, closing, closing. Dial reset. Okay, let's check out this radio now. Antenna's still connected. What happened to the light? We don't need it now. Incidentally, these lights, I'm going to give you a little trick here. The actual filament needs to line up with this edge of the glass, which is dirty. Then you get a maximum blast of light right from the filament right down the glass, and it'll light all these numbers up like magic. But if you just have it over here and it's not lined up, then it casts light in a clumsy way, and it still looks kind of okay, but you're not getting out of it it's not looking like what it really should look like. So this is critical and very tricky on a lot of radios to get it lined up just right. Some radios, they got the wrong light bulb in it. There's no way the filament is going to make it. We're not hearing anything. Now we are. Okay. Let's go on the AM band.
Actually on Dawes Road from Gower to Ferris. That's all because of a fire investigation that's going on right now. So Toronto Police and Toronto Fire getting out there to investigate. So they've shut down the entire portion of the stretch through here. Again, the main intersection around here, it's basically on Victoria Park between Danforth and St. Clair. So again, the east end of the
I think we're listening to 680.
And, in terms of what else is happening in the major routes, major routes, I should say. Again, that crane hoisting going on. Construction shutting down Wellesley for a portion from Queen's Park to Bay.
Surprisingly good signal for 680, so maybe it isn't.
Insurance Group. Call 416-239-3373. That's 239-3373. The following is a paid commercial program. Unless otherwise identified, the guests on the program are employees of the advertiser. Opinions expressed are those of the advertiser and do not necessarily reflect the views and policies of Global News Radio 640 Toronto.
640. There we are. 10, 20, 30, 40. It's bang on. Man, that's quite a pointer job I did there. 590.
And his son-in-law has a question ready for you.
Buffalo. It's a great radio.
C'est aujourd'hui du côté de ceux qui protègent les animaux, puisque les travaux sur la conscience animale, sur la souffrance...
band is crunched up here. Look at that. So like here's 600 to 700. There's this wide down here for 200, and 200 is jammed into this little space here, up here. Wow. Sounds like there's a hum that comes in with the station, if you listen.
One from the diet, yeah, and two is from the bones. The body will absorb it back from the bones if it needs it? That's right. I see. And what you just discussed right now leads to one of the major causes of a condition that's affecting 25 million Americans right now, which is called osteoporosis. Right. Which is a weakening of the bone. Now, and that's due to the body deriving the calcium from the bones instead of...
No. Come on. Osteoporosis. Hey, we're all heading for it. You know how that... I'm going to tell you how that works. Osteoporosis. So your bones have two processes. One is building up the bone, and the other one is tearing it down. And this is constantly going on all your life. It results in something called bone remodeling. If you've ever broken a bone, like I broke my collarbone, the collarbone seemed to heal on its own. It wasn't no treatment, and then seemed to readopt its shape again. And this is because of bone going in and bone coming out all the time. The problem is when you're older, the bone going in process gets weak. And calcium keeps coming out. Not bone going in, it's calcium. Calcium keeps coming out. Calcium not going in. The only way to fix that is with medication. That's my understanding. You can drink all the milk you like, you can't even absorb the calcium in milk all that well. So for those of you who are around my age, and I suspect it's quite a few of you, when you see people, older people bent over, and I'm sorry if you are an older person bent over and you're watching this video, that's osteoporosis in the spine. That's a one-way trip. You bend over, you don't straighten up again. So this is a really serious thing, and that's why I'm talking about it, because of that little bit of misinformation that got tossed out there. We should all be on medication for osteoporosis. And I am not. having given the osteoporosis speech, I now admit that I'm a failure too, just like everybody. I'll wait till I'm bent over and it's too late. Too late. Yeah, okay. Enough of that nonsense. Okay, let's give this radio another go on shortwave.
Are you on high blood pressure medication? Do you need something for your kidneys? Are you on pain medication? Do you need sleeping pills? Does the calcium and especially the magnesium being absorbed? You're not going to suffer from all these things.
Yeah. I don't know who that guy is, but I don't think he's an expert in what he's talking about. Shame, shame, shame. Here we go. Now we can read the dial. Let's get a strong station. May not be a strong one right now because wrong time of day. Any station. I'm not going to be able to identify it. What I was hoping to do was identify the station and just check on the internet what frequency it is. But instead, we'll do something a little more direct here. We'll hit it with my signal generator. Just make some loose coupling here. Quite a bit of heat coming up from there. Transformer cool. Okay, now we're going to attempt to figure out what frequency we're listening to. So it's 9. Right now it's on 9350. Let's see what we get here. Should be able to hear this. That was not it. Nobody home? Okay, we'll get a little higher. Well, I just realized I had my phone in my shirt pocket here, so you may have been hearing my phone data transmission going on the video. Apologize for that. That's the case. So here we are. So 39387. So 9390. I see we're quite a ways off here. $9650. $9690. 9690 is actually, I think, right up in here. So a little off, but hey, it's receiving. Great. This is really great. I'm just so excited about this. Okay, what's the next step? Now, I could fiddle with the alignment to bring the performance up to maximum, and then start the capacitors and see if we can get any more out of the radio from doing capacitors. That sounds like a fun way to go. So first thing would be the Iaf. We need to look at the Iaf alignment instructions here. Well, here's something a lot more interesting than checking the alignment at this point. It's a nice table of voltages here. Let's just check this out here. Take all readings with the radio turned on. Tuned to 1000, no signal. Line voltage 117. Use a good high resistance voltmeter having a resistance of at least 1000 ohms per volt. So they got these with a good voltmeter. Read from indicated terminals to chassis base. See a location chart. What are these notes over here? Tuning eye, don't have one. No, this is a different model. 662, mine's a 552. That's all about the next model up, I guess. So the numbers that are italicized are AC voltages. Coming right out of the transformer, I think. There aren't any others. Yeah, this is the heater voltage. Minus 0.6. We're going to try to read that. I have them here too. These must be the grid. Oh, I don't know what. We'll find out. Let's do these. That sounds like a good idea. Okay, I got the table up on the screen there. We're going to use this meter here. Let's just a little over that way. Flip this guy up while he's operating. And then I need a little block. There we go. Okay, now let's get the meter ready here. All readings are done relative to the chassis. There we go. Our first reading would be modulator, oscillator. Interesting to use the word modulator. 6SA7, pin number 3. 6SA7. Pin number 3. It's a 6SA7. Pin number 3. Well, we'll try it. 1, 2, and 3 appear to be connected together. Nothing whatsoever. Let's just check my meter. That's a B plus. 300 volts, by the way. This is packing some punch. So we should find 300 volts. So I either got the wrong tube, or I've got the wrong pin. You know what? That could be the wrong tube. I think the right tube is in here. Oh my gosh, how much? Yeah, that's right. Right there. Right where? Oh boy. It's just smothered in parts. So I'm trying to see the key on the tube. Sometimes you can see the key in the socket. You can see the key slot just in the socket. And sometimes you can't see anything. Okay. Well, let's see. That first tube, it's got a bunch of voltages. 250, 110, minus 12. Well, let's just poke around. Now, it says 1 and 2. It just has a dash, so that doesn't necessarily mean there's nothing there. Well, let's try this pin. So I have the meter very... Oh, you can't even see it. Oh. Okay, let me fix things up here. That's a bit better now. So voltage. Once again, the B plus. We're on the 500 volt scale, so it's just under 300 there. Back to that tube now. Getting home there. Okay, so on this we are getting about 140 volts. Now what does that match with? There's 110 there on pin 4. So if that's pin 4, we'll find 250 next to it. So what was this one? Oh yeah. Don't be so scared, Ken. 300. Instead of 250, the radio is running with 100 volts in the outlet. It's actually, the recommendation is 117. That's not 1,025 volts there. If I raise the, I can raise this by getting rid of the dim lights that are in the circuit. We're going to get even higher voltage. Let's try checking the, let's skip to the last tube there, the 5Y4. And let's see the 310, if we can do it. 310, switch my meter to AC. Okay, 310. Now the rectifier tube is right here. And look and see the wires coming out of here. So it looks like these two are the heater. This one is the positive takeoff, I think. And we're on AC there, so maybe shouldn't try reading it. This would be right from the transformer here. So again, we're on the 500 scale. That's no 300, that's 150. Yeah, things just don't make sense, do they? 500 volt scale. Oh, you know what? There. It's gonna make sense now. So a little under, so 310. And what is it supposed to be? 310. Wow. Now that's going to go up. Here's the other one right here, I think. 310. So if let me give it, I'm going to give it. Let's go. Where'd it go? I can't give it when it's gone. Let's get this on here firmly. And now, hands clear? Yep. So it's close to 400. Full voltage. Wow, that's like 100 volts over and above. That's quite a bit. I think I'm going to leave it on the dim bulbs here. Because that's a lot better, huh? They just include 2 light bulbs with this radio. Well, that's a little odd. How can that go high? The transformer's a transformer, isn't it? Not as much load on the transformer as it's expecting? No, that can't be it. I don't know. It is what it is, though. Okay. Now, working with this is the correct B+, so I should get the correct readings. That's my theory. So I go back and we look at the B+ coming out right out of the rectifier tube. Just a hair under 300, and up there it's a hair over 300. Now you could argue my meter's not that accurate, but for sure if I flip it up to full line voltage, that's good though. That's good. Let's check the output tube now, and we've got 240, 250, and 16. So the 16 is the bias. So output tube is this great big honker right here. The resistors around it look good. I'm looking for a cathode resistor that's overheated. I don't see it. Can you see the key and know what pin we're touching here? Oh yeah, I can see it already. Okay, pin 1. Pin 1 right there. Ready on DC? Yes. Okay, on the chart, pin 1, 2, it's 3. That gives us the 240. 1, 2, 3. This should give us the 240. And we got 275. Okay, and the next one over should be a little bit higher. So look at that meter there. It really is 275. Slightly higher. Yes, it is slightly higher. And now we're going to pin 8 to try to read 16 volts. This is quite important. So pin 8 would have to be here. 16 volts. Okay, 16 volts on the 50 volt scale. And 50 volts, so that's 17, that's 18 volts. Higher is a little bit better than lower. The radio sounded perfectly clear when I was listening to it. I got no sensation that there was anything going on in the output tube. So that's good. This is all checking out quite nicely. What else we got to check up there? The Iaf Amplifier. The 6SK7. So that's this guy crammed in amongst the 2 Iaf transformers. And we should find starting pin number 6 on 105, or pin 8. I can spot pin 8 on this tube. No problem at all. Pin 8's leaping out at me. So, oh, I've already checked this. Wait a minute. Whoa, 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 whoa. That's the rectifier tube. Up here. Pin 8. What was it? Pin 8 is 250. 250 on pin 8. 500 volt scale. Straight up. So 290. And then 105 on 6. Yeah. Minus 1.8, minus 0.5. Those are probably tough to read, but let's try it. Pin 5. Pin 4, almost knocked the radio over. Pin 5 minus 1. I'm on the 5 volt scale, so I better hit the right pin now. And it was 8765. Pin number 5, is that right? Pin number 5 is minus 1.8. Didn't I put it on minus? I did. Am I reading that chart wrong? Minus 1, Iaf Amplifier, minus 1.8 on pin 5. Right beside the... So again, get the right tube. Did I have the wrong tube? 1, 2, 3, 4. I'll count the other way. 8, 7, 6, 5. This is 5. 5 has a positive voltage on it. 5 has a positive voltage on it, and that's about 3 volts positive. When I was working on this capacitor and replacing it with this one, and I went to work on this part of the lead, I discovered it wasn't soldered. It was loose in the connection where I have this red wire now. Ooh, what was that? There was a pop in the radio just now. Could have been something in my house being turned on or off, or could be the radio is seconds from exploding. So what to do about that? There's another one right beside it, should be minus 0.6. There's that pop again. I think it's something external to the radio. IF. Okay, so this one should also have a negative, so this should go backwards on the meter. Okay, it went backwards. Now how much? Wow. Oh, yeah, DC. Could be, yeah, I don't know. To tell you there, but that is a 5-volt scale, and there's just a dribble there. So 5-volt scale, yeah, that's nowhere near what it should be according to the chart. Something going on with the 6SK7. Oh, there's a 250 there. I did check that. 250 and 105. It's 5 and a 4. One of those is the grid. Which one would it be? 6SK7. Let's look in the book. Look in the book. 6SK7. There it is. The grid is pin number 4. Pin number 4, and so pin 4 is grid. Pin plate is 8. 8 and 6. 6 is a screen. 8 and 6 should have voltage on them. Is that what's up there? 8 and 6, yeah. That's exactly right. And then pin 5. Pin 5 is cathode. Oh! Pin 5 is the cathode, and why are we reading minus? Supposed to be reading minus there. Well, I'll have to study the schematic a little bit. And we should do that. Find out what's going on. What's going on? That's why we're doing this. We're doing this to find out what's going on. So, oh, the schematic's right up here. Look right at it here. So 6SK here, cathode here, cathode. Ooh, very hard to see up around and down. Oh, there's a cathode resistor right there, 270 ohms. This side should be positive to ground. Raising the cathode positive makes the grid appear negative. The grid, this is controlled by the ADC here. Pretty sure I remember seeing that. Yeah. So that's an error in the table. I hate trying to draw that kind of conclusion. But this should be plus. Wow, it's hard to believe. In fact, all these are showing negative on pin 5. Negative on pin 4. What's going on pin 4? Wait a minute. Did I get something wrong there? Maybe I did. Pin 4, pin 5. Yeah, pin 5 is the cathode, right. Pin 4 is the grid. So you expect the grid to be negative relative to the chassis. if anything, it's driven by the AVC voltage. The cathode should read positive. Same as this one. And did I catch this -6 here? Did I catch this -12? Sometimes there can be something funny going on in the power supply to enable a negative voltage in the radio. Is that happening? So you would look for a resistor, I think it would be in here. You sneak it in here. Don't see it. So if this guy's getting biased by this resistor, and what about this guy? Oh my gosh, how can you figure out where the cathode is here? Ah. I apologize if this isn't coming up on the screen 100%. I wasn't paying close attention. Here we are. Trying to follow the cathode lead. It goes out 6. Goes down. Oh! Gets into this oscillator. This is the oscillator. So the oscillator coil here is got the cathode current going through it. It's that style. So far be it for me to sort out that there's some kind of bias resistor in here. I don't think there is. So the entire biasing would be on the grid itself. If we follow the grid, here it is. Wait a minute, this is the oscillator grid. We want to follow this one. The grid 3 comes out of 8. Select this way, that way, and I traced this the other day. The AVC voltage is sitting here. So it's being biased by AVC voltage. I see, I cannot explain this negative number here. Let's go back and look at this one. 6SA pin 5. I never saw a negative thing there. 6SA pin 5. Can we deduce which pin is pin 5 by componentry? Pin 5 on 6SA7. Pin 5 on the 6SA7. Pin 5 has a 22,000 ohm resistor going to ground and then a small capacitor off it. $22,000, so it's red, orange. Red, orange coming off of that pin, going to ground. Red, orange coming off the pin I want. So there's a red, orange right there. Coming off the pin I want. It's going to another, no, it's going to ground. So this is it right here. This should show us a negative voltage of 12 big volts here. We're on the negative side, 15 volt full scale. Ready for you. Do your thing. Well, I don't think that's any 12 volts. 12 volts is way up here. Broadcast band. Ho, 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 ho. It did say broadcast band around 1 million. Well, I don't think that would have affected any other So there's the minus. Hey, so what happened to the minus that I was having trouble with? The minus that was a plus. Let's try that again now. 6SK7 pin 5. SK7 pin 8765. Okay, now the meter is set for a negative reading, 15 volt scale. Still reading positive. Positive 3 volts. Positive 3 volts. Supposed to be minus 1.8. Okay, so let's look at that closer on the schematic. Pin 5 of the 6SK7, how can it be driven positive? So pin 5, oops, right here. Pin 5. It is driven positive because it has a resistor here. That's got to be an error in the table. I hate to come to that conclusion. I really do. So if you're using this kind, so let's look in the manual under 6SK7. It'll give us some hints about resistors and stuff. See if this is in the ballpark here. 6SK. Are we in the ballpark? Plate voltage 300 max. So when I put full power on this radio, it's 400 sitting on this tube or close to it. When it says 300 max here. So typical operate characteristics. Plate current, it's not going to give it. Plate voltage 250. Plate number 1 voltage -3. So that's what we're reading when we're reading the +3 in the place where I'm reading it. We're really reading -3 on the grid relative to the cathode. So it's right on the money, according to this, with 250 volts on the plate. Well, I don't see how that can be any other way than the way I just said. I think it's a false thing. I'm going to have to leave it at that. I hate that. I really... I usually lose the disagreements with the schematic in the long run. So I know I'm on thin ice when I start arguing with the service manual. But I don't know what else to do. Okay, back to where we are then. Voltages seem good. Radio working good. Alignment check is really what's in order now. Just a quick check of the alignment. We can do this pretty easily, but I want to make it a quick check. We'll take the output of the signal generator here. I'm just going to lay it near the antenna. I'm going to try to drive an Iaf frequency signal into the radio this way. And we can find out pretty quickly if it's really near where it should be. You know what? We can turn this into a way to monitor the ABC very easily. Why don't we do that? Take the volume control, pick off. Well, that's not the volume control. Down here. Pick off the input side. The input side is hidden. Hidden away. Oh man, it's not so easy. Not so easy. It's worth having though. We're doing a quick check, but don't worry about it. Our ears will be the meter. So what I'm going to do now is I'm simply going to drive my signal generator over here until this number is 455. Now the radio is tuned right near that. That's not what I'm interested in. 455. Okay, so nothing. Came out. Let's just get a little more brutal here. We're going to pound the signal right into the radio. Radio antenna. Let's take off the other antenna. Take it off. Oh, don't let the clip lead go flying like that. ground wire is laying right across the antenna coil. Oops, I want to turn that one off too. Now we're going to blast in the 455 here. Turn it up. Nobody. There we are. Now just by ear, listening to where it's loudest. .465, and I'm quite certain it's supposed to be 455. Maybe just double check that somewhere. I saw it somewhere. Where did I see it? Sometimes they write it right around here somewhere. No. 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 Oh, it's going to be in here. Okay, just want to double check this because I'm sure I've got it right, but... Oh, 460. I'm wrong. 460. I'm sure I got it right, but I'm wrong. How does that happen? What's the matter with human beings? Okay, so 460. So considering that, reconsidering that, yeah, it's 464. Close. And the other alignment issues, you can't really fiddle around with them quickly and assess them. But you know, obviously the radio is working and has a fairly decent sensitivity. Let's see what to do next. So I have all these capacitors staring at me here. Why don't let's peak the radio for performance doing an alignment, and then go after these capacitors as I proposed before, trying to anticipate which ones are probably going to be dragging the radio down the most. Can't be dragging it down much. If I align the radio with bad capacitors, it's a chance I'm aligning it not really where it should be once the capacitors are replaced. So that can cause a lot of confusion in trying to assess this. And yeah, confusion. Confusion's my middle name. Okay, we're going to end it here. And alignment is the deal.